Hey everyone, welcome back to my YouTube channel Knowledge Odyssey. Today I'm super excited to kick off a brand new series on network theory, one of the most important and fundamental subjects in electrical and electronics engineering. Whether you're a student preparing for exams, someone brushing up on the basics, or just curious about electrical circuits, this video is for you. In this series, we'll break down complex concepts into simple, easy to understand videos. We'll cover everything from basic circuit elements, Ohm's law, KVL, KCL, to more advanced topics like Thevenin's and Norton's theorems, mesh and nodal analysis as well. Each video will build on the previous one, so by the end of the series, you'll have a solid understanding of network theory. So make sure you hit the subscribe button and turn on the notification bell so you don't miss any episodes. Let's make network theory simple and fun together. Let's get started. So, this is the first episode in a network theory series. Firstly, what is network analysis? Network analysis is a structured technique used to mathematically analyze a circuit. So, if you are given a circuit, you have to understand what are the things that are going inside it, right? So, for that, we use network analysis. And also, firstly, an electrical network or a circuit is a system of interconnected components. So, we have to know about the components, right? So, let's jump into the network components. The first network component is a resistor. A resistor is a component that opposes the flow of electric current. It converts electrical energy into heat energy. The resistance is measured in ohms, which can be symbolized in this symbol. Resistances are used to limit current. The most important use of a resistor is to limit flow of current. This helps to protect the components in the circuit. So if you see here, this is how a resistance is denoted, resistance or resistor. Every resistor has a resistance and let us assume it as R. In the small circuit shown, there is a current I flowing through it and also there is a voltage difference between the two ends of the circuit, which is V of t. So if you go to the equations from this circuit, we'll get voltage V of t will be equals to R into I of t, and in the same way we can get current, which is I of t implies V of t by R, and this is in the time domain. And also we can also write it in S domain. S is nothing but frequency domain. We'll further discuss about this in the upcoming videos. So just remember I of s equals to V of s by R, or you can also get this in form of V of t, which is V of s equals to R into I of s. So these are some basic equations from resistor. And now next we are going to see the important law that a resistor follows, which is called as Ohm's law. Ohm's law states that voltage is directly proportional to current for a given resistance. So V is directly proportional to I. The next component is inductor. An inductor opposes sudden changes in current. It stores energy in the form of magnetic field when current flows through it. So the main role of inductor is opposes sudden current changes. When you suddenly try to change the current in a circuit with an inductor, it resists that change. This makes inductors very useful in applications like filters, transformers, and energy storage in power electronics. It has a property called as inductance. And this inductance is denoted by H, which is called as Henry. So if you go to the symbol of the inductor, this is how an inductor is denoted in a circuit. Here we have connected an inductor with inductance L, and there is a current I of t flowing through the circuit which has a voltage drop of V of t. If you go to the equations, here we have the voltage V of t is L into d by dt of I of t, and also from this we can get current I of t, which is 1 by L integral minus infinity to t V of t dt. This is in time domain. If we convert this into frequency domain or S domain, it will be I of s equals to 1 by S L into V of s, where L is the inductance and S is the constant for S domain. Also we have impedance. Impedance is something denoted as ZL, which is equals to S into L. So this SL is called as impedance, and admittance is just a reciprocal of SL, which is denoted by Y of L. Actually S is equals to J into omega, where J and O is an imaginary number and omega is 2 pi f. So with S equals to J omega, we can write impedance ZL equals to J omega into L, and also admittance YL, which is equals to 1 by J omega L. We can also write it in S domain. In S domain, V of s equals to S L into I of s. I have written here, right? In time domain, voltage V of t is L into d by dt of I of t. But in the S domain, which is V of s equals to S L into I of s. where we know that S is j omega, so we are writing V equals to j omega L I, where current I equals to 1 by j omega L V. So the next component is capacitor. A capacitor opposes sudden changes in voltage. It opposes voltage change. It stores energy in the form of electric field between its plates. It has a property called as capacitance and it's denoted by Farad. F. Capacitors are used in timing circuits, filters, energy storage, and for smoothing out voltage fluctuations in power supplies. In DC circuits, once fully charged, a capacitor blocks current built in AC circuits. It also allows current to pass, which is especially at very high frequencies. And if you go to the symbol of capacitor, this is how a capacitor is denoted in a circuit. As you can see, we have connected a capacitor of capacitance C in the circuit of current I and voltage of V of t. And also if you go to the equations of it, we have I of t equals to C into d by dt of V of t. From that we can get the voltage V of t equals to 1 by C integral minus infinity to t I of t dt. This is in time domain, and here we have in frequency or S domain, which is I of S equals to S C into V of S, and V of S is 1 by Cs into I of S. As we know that S is j omega, remember it, this is small omega, this is not capital omega. So I equals to j omega CV, and from that we can get voltage equals to 1 by j omega C into I. So thank you guys for watching this video. In the next upcoming videos, we are going to discuss about different sources, and also we'll give a basic knowledge about nodal and mesh analysis. Thank you. Please do like, share and subscribe and turn on the bell icon for more interesting videos.